What are the elements of successful
Okay.
semantic models? That's a good opening.
It's a big, broad question. And this is one, remember, this is not a lecture. So I'm going to give my opinion about this. But I know a lot of folks here have a lot of experience with data models, even if not semantic models. And one of the things that I have found in my own practice is that some of the best semantic modelers I know are data modelers. That is, they've done data lakes, data warehouses. They have thought about the durability of their data models. And since you've read the first 3 chapters, one of the ways to think about a semantic model is that it's a durable data model. Now, I see people raising their hands. I'm not quite sure what that means at this stage, Ellie. So maybe you could chat with him private and see
I
if
think
he wants
it's
to
the
bring thing in.
same hands that were up from
Oh,
scratch.
okay. I just got a new notification of it. All right, that's kind of
Yeah.
weird. All right. So, a good semantic model is really a durable data model. That is, it has to be something that can comment on a lot of data sources. We're in a distributed system here. And that means that if you've been doing a data warehouse, a lot of your data warehousing skills also apply to good semantic models. And so I suppose one general principle to answer this question is durability and interoperability, that it's got to interoperate with a lot of other systems. And so along those lines, so how does the question asks elements. I can't give you a recipe book. I'm not going to give you a shopping list for what makes a good semantic model, but I can talk about requirements and approaches to that. And so if we're talking about a distributed model, that's going to be durable, that's going to map to, as you will, other data models, there's a principle which in this book is only briefly touched on. We touch on it again in chapter 15 when we are coming back to the notion of modeling again, with the perspective of the rest of the book. And so we can come back to this question then. But one of the principles that I think is really underrated in semantic modeling is one that I call commonality and variability. Now, I call it that. I didn't invent those words. There's even an OMG standard for commonality and variability, which I think kind of misses the point on a lot of things. But the idea of commonality and variability goes back at least to the 90s in the field of software reuse, and the idea that you're building software for multiple uses. And one of the insights from that work, and I can give you some references on that if you really want to follow it up, is that what you're really doing when you build a semantic model is that you are looking at a number of systems, many of which you haven't even seen yet. And how do you predict what some data system, I'm using that word very generally, is going to look like if you haven't seen it? And that's where you look at the ones you do know and you find out what do they have in common and how do they vary. So if you take as a simple example, I'm going to go to a FIBO example just as it's at the top of my head and I haven't prepared for this. You have some financial instruments. So that's what FIBO is about. It's the financial industry business ontology. We'll talk more about it in chapter 9. It's a model of financial instruments. So there's a notion of a financial instrument. What is a financial instrument? Well, you can describe a financial instrument as something that can be traded, something that has a value, and so on. And there are particular instruments. There are loan instruments, there are securities, there are a bunch of things. One kind of instrument is a thing called a swap. Now, a swap, when I say swap, there's a whole bunch of instruments that have something in common that makes them be called a swap. What is that? That's what you model at the level of swap. And it happens to be something like it has two streams of payments, and the payments get paid by the opposite payers, something of that sort. You can look into FIBO for a detailed description. And all swaps have that in common. That's the common part. Then the variation is, but wait a minute, there are different kinds of swaps. There are the credit default swaps, which were quite famous about 12 years ago in the financial crash. There are interest rate swaps, which are a lot more benign and a lot more common, and other kinds of swaps, currency swaps. I don't know what they all are, but that's FIBO's job. So when FIBO has built what I think is a pretty good model of swaps, at the high level, you have commonality, the notion of swap. At the lowest levels, you have variation. Well, interest rate swaps versus default swaps, currency swaps versus interest rate swaps, and so on. And you got the variation. And then you can play that game over and over again. Well, interest rate swaps, there are a bunch of kinds of those, right? There are float, float, and fixed float, and so on. They all have in common a certain structure, but they all have a variation of a certain structure. And so to my mind, the elements of a successful semantic model is where you have, in some sense, predicted, and now not predicted as in horoscopes and crystal balls, but predicted as in the way machine learning predicts things. You actually look at your data, and projection might be a better word than prediction. Project it forward, and that the model actually manages to cover the variation and commonality in the domain that it's about. So I'm going to stop talking now because this is a book club and not a lecture. And since I bet we have a lot of data modelers in the crowd here, I'd like to hear some comments from you if you've done data warehouses, data lakes, and stuff like that. How you would approach this question. I guess we could do that with a hand raise if you want to raise your hand, and then Ellie will recognize you and then unmute you. So it looks like Jeff raised his hand.
Yeah, you want me to go ahead or you want me to wait for?
Yeah, go ahead.
Okay, sure. Yeah, real quick. I mean, I think, in data modeling, that's where I was first introduced to, super typing and subtyping. And of course, that's huge, as I've come to understand from the book, in semantic modeling. And it takes it one step further with actually being able to really make inferences off that. So right away, that alone, that's a nice separation between the commonality and the variability. At the common level is the super type, and then you become very specific and very narrow in your data model as you subtype. So that's what came to mind when you were talking, Dean.
Okay. And now you followed on the notion of commonality and variability that I talked about, but I'm thinking that some other folks with data modeling or enterprise modeling experience might have some other, I think there are a lot of aspects. I brought up that one because that's one that I think is sort of underrepresented, but I'm thinking that some of the data modelers in the room might have some other ways that they think about what makes a good data model, what makes a data model durable, what makes it a data model good for a warehouse or something like that. So I want to see if I can convince somebody else to raise their hand and make a comment
or
about
even
that.
maybe what are some of the problems that
good idea. Yeah, thank you, Ellie.
We have Jim in the chat telling us he'd go with modularity.
So modularity. So Jim, well, I didn't see that you were here. One of the things I often struggle with is what exactly does modularity mean? And if you have some comments you could make about that, I would appreciate that.
I'm not sure if he can join.
He might not be able to use his voice.
Yeah. I can.
Oh.
And there's a lot of background noise, but I'll work in between. Real fast, the notion of the monolithic ontology or the monolithic model, there are times where it makes sense when you're in a domain, but even then you tend to have naturally occurring subpieces. They may be linked together. So even if you look at something like FIBO, even though it's all one big thing, it's not represented as separate files, quote unquote, it still has conceptual blocks that you could reuse somewhere else. And that where we've really seen the most of that is in a lot of the bio-ontology work.
Yeah.
Where people will find different ways of reusing term. There's a whole literature out there on ways to essentially refer to terms in other ontologies rather than building your own. But when you can refer to a set of terms or everything that's under some superclass term, that's when that's a real value. And so we now develop a lot of our ontologies thinking of them as separate pieces linked together so that you can pull in a piece, know what the references are. And of course, the semantic web, by the naming conventions of URLs, was designed to allow that.
And so I guess, Jim, one of the things that I find puzzling about the word modular, because I agree with everything you said. And by the way, in the back end, FIBO actually does separate all that stuff out by files in lots of different ways, is if I were to look at an ontology, like say FIBO, and say the modular structure of that is good, and I look at another one and say the modular structure of that is poor. What are some of the criteria that one would use to say that something is modularized well or poorly?
You know, again, as in so many other things in these kind of modeling designs, I don't think that there's a single answer. But where you have conceptual separation, so for example, again, I use the bio examples where you go all the way up from DNA to population health, right? Often you have a similar term in different contexts, things like that. When you give them different names and then can, again, make it so that you can find the pieces as opposed to finding the individual classes and things like that, that's useful. And a lot of the, we'll get into this, you know, I think you get into this in later chapters. 5 will have some of this. That's part of what Shackle's about. Things that is actually being able to say, here's a conceptual piece that's separate. So it's really, you know, sort of when you have a set of terms that cluster together and are only lightly linked to the rest, to some other set of terms, it's being able to find those by any of the various mechanisms that are defined in the book.
And of course, one of the key capabilities of RDF that allows it to be a good language for managing modularity is the fact that all of the resources in RDF are identified by these global identifiers, the IRIs. And that means that when Jim was just talking about this loose coupling, that the loose coupling is I'm referring to something by its IRI out on the web. Tight coupling is that I'm putting it all under the same governance, all into the same file, and so on. So one of the things that RDF provides towards modularity, you're not answering the questions that I was asking you, what is a good module, what's a bad module, but RDF provides a sort of technical capability for managing your modules so that whatever policy that you take for saying, yeah, here's how I'm doing my modularity, RDF gives you a way to do that.
Would a well-structured set of competency questions provide a guide to how to modularize?
Well, of course, that the key in that question is well structured, isn't it? So
I suppose.
I often find that competency questions have a bit of a tendency to kick the can down the road. And not to say the competency questions aren't a good idea, but the problem is, you know, you guarded your talk by putting in that word well structured there, because I'm sure that you're aware that competency questions can be written very well or very poorly. And I have seen competency questions that are written so poorly that, and this is no, and I don't even think it was the fault of the person writing them, that basically writing the competency questions themselves was a modeling process, and you kind of had to beg the entire question to write them at all. And so the answer to your question is yes, but the key is inside of that well structured caveat there. And if you structure your questions well, then you've kind of done some of the modeling up front, and in particular, the part you've done is the modularization. Now, Bill just talked about competency questions, and I don't think that notion was in the first 3 chapters. I don't remember. I did actually read them. I'm going to do all the work that you guys are doing, and it's very painful to read your own writing, right? So, but I don't remember the competency questions are in this chapter. So just for the sake of folks who might not know a lot of the literature here, going back about 20 years, one of the seminal papers in ontology structure, and it really predates OWL, I think, goes back into the 90s, talked about methodology for ontology modeling. And probably the most durable part of that paper 20 years later is this notion of a competency question. And it's kind of just ordinary good engineering practice applied to ontology. I mean, part of this is just an ongoing understanding that we can treat ontology design as an engineering principle. And this is probably the first step in that direction. And so the idea is that your requirements that you would have had in normal software will be expressed for ontologies in the form of questions. And these are questions that the model should be able to answer. So the questions can be of the form, there was one example I was doing the other day of media. Is this television show dubbed or is it subtitled when you're doing translations? So do you need to answer that question for your use case? It's a very specific question, and the model could model that distinction or not. The idea of the competency questions is that it's easier to think about the questions that somebody would want to ask about the domain of a model than to actually build the model itself. And what we're really getting to here is that one of the problems that people building semantic models have, there's a little bit of a digression from the question, but I think it's more of a workflow answer rather than an elemental answer, is that it's actually pretty easy when you're building a model to get carried away with the model and with the subject domain and just say, I'm going to keep on modeling here and never think about when it's time to stop modeling and when it's time to start mapping data sets or building applications or something like that, and just get yourself into a pure research mode of doing research for its own sake. The idea of competency questions is to have a very low entry point starting spot where you can just list out your questions. And what Bill was alluding to there is, well, if you just list your questions as an unstructured list of 1,000 questions, have you really helped yourself? And by saying well structured, he's now I'm putting words into your mouth, Bill. Putting the questions together into categories, into similar topics or similar structure. And the gist of his question was, if you do that well, wouldn't that give you a good definition to my question? When is a module good and when is it done poorly? And so in some sense we're kicking the can down the road, Bill. But I think that just in as much as that competency questions are typically easier to manage than the logic of an OWL model, that we're not kicking it that far down the road. We actually have made a little bit of progress there.
Thank you, Dean.
All
There was another hand up, wasn't there, Ellie?
Yep, we have Stefan up next. Go ahead and unmute yourself. It's been a few minutes. Stefan, are you still with us?
Yes, I am. I'm just trying to be seen. Yes. Yeah. Thank you very much. I think you also half answered my question, because I'm with the German National Library. I'm surrounded by metadata experts and data modelers, but I'm a T guy and a product guy, and so I'm always looking for that sweet spot where you can actually have a product, and that's why I would ask for frugality or sparseness, maybe, and then extendability as a properties of a good data model. But of course, you have to do your homework, that you don't cheat your future self out of a proper analysis of the domain you're modeling, and not run into problems 2 years down the road because you thought of the basic questions. But still, I'm suffering from people putting 3 years into terminology work before we can even start thinking about a product. And so, yeah.
Well, that's the scoping issue that I was alluding to in my previous comment, that I've been involved, as you have, in any number of projects where the project was proposed as a modeling project and the modelers get started. And somewhere down the road, there's the product developers like yourself, or the application developers, or the data mappers and so on. And they wait for completeness of the model before they get started. And that means that you never start your job. And Jim Hendler is, I think, still most famous for his quote, a little RDF goes a long way. And one of them, I'm going to now interpret that statement.
Excuse me, a little semantics goes a long way.
Okay, so
and we later turned it into RDF.
Okay, I wasn't quite sure which way that went. Okay.
It predates RDF significantly, Dean.
Oh, okay, good. Then that'll help me remember what order it came in. But one of the ways to interpret that, and I think part of the reason that it's so durable is there's a lot of ways to interpret, but one of the ways that I interpret it is that the modeling process should be iterative. That is, the story you just told, you shouldn't sit here and wait for your vocabulary to be done before you move on to whatever your products or applications or mappings or so on are. That you should have some sort of an iteration built into this so that you can do a little bit of semantics, get some value out of it, do a little bit more semantics and get some more value out of it, and so on. Because it is awfully easy to get into a frame of mind where you're waiting for the semantics to be done before you move on and get any value from them. And not only is that a bad idea, it's also not necessary. And that's the point of Jim's comment. I know, Jim, I just put a lot of words into your mouth. Do you want to correct me or fill some more stuff in? I'll take
You
that.
did better than I could, Dean.
Okay, all right, very good. All right.
We've got another question
Yeah,
from
thank you,
Andy
Ellie.
Fitzgerald.
Yeah, thanks. Dean, my background isn't in data modeling, it's in information architecture. So
Okay.
there's like navigation, structures, helping people find things on the internet and understand what they find. And in putting together classification schemes and navigations, one of the challenges that I often negotiate with clients is whether something is a class or whether something is an attribute. So whether it sits in the class structure or whether it's something that we're going to tag within that class structure and across different classes and different levels. And I'm curious to hear if that in Jim's experience is something that comes up in creating these kinds of models and successful semantic models, and how you negotiate it.
So yeah, that actually happens in my practice quite a lot, and often not so much in the pure modeling activity. I sit down, get your competency questions, and start to model. I actually quite like to do a lot of bottom-up modeling. As I mentioned earlier, I have great respect for the data warehouse modelers out there, and I'll often look at a data warehouse model and find that they have struggled with the same issue, and that they have said, do I make this a table? Do I make it a column? And in relational databases, you have a lot of technology limitations, and so that influences their decision. And then when you're turning that into something you're going to be doing in a semantic model, then you're faced with the same thing. I could just model it as a property because that's the way that the database did, but am I now carrying on the baggage of the relational database with me? And often my colleague Elisa Kendall, who I work with in a number of projects, will often come to me and say, well, look, if I just do it as a property like they did, the mapping is really easy. All of our infrastructure works really easily, but I don't feel like it is a property. I feel like it's more of a class. Now, from a modeling perspective, this is way beyond what we should be talking about in this chapter, but in chapter 14, 13, when we get into OWL, we actually can come back to this. And and I'll give you just a quick preview of that because I don't want to go into too much detail. But in OWL, you can say things like the set of all things that have the value true for the property is male. And you could say, gee, normally I would call that class man or something if we were talking about humans. But it's a almost facile example of this. But you can actually describe the set of all things that have this value for this property and give that class a name. And that means you can logically describe the relationships between representing as a property and representing it as a class. And that means you could actually have your cake and eat it too, if you're willing to buy two pieces of cake, right? And because there is a cost to that. But the interesting thing about OWL is it does provide you the logical capability to do it. Does that mean you should? Yeah, let's keep all this until the chapter whatever discussion. But I certainly do run into that, and it also interacts with the notion of how much respect do you pay to your legacy models and how do you map them. But it's worthwhile understanding that logically, it's actually not a problem, because logically you can describe the relationship. And if you sort of ignore the mere fact that logic sometimes is expensive to compute, from a conceptual point of view, you've basically described it both ways. And I actually have an example in chapter whatever, where there are some times that you really wish that you were modeling it as properties, and sometimes you wish you were modeling it as classes. And so we actually do both, and then show how the logic lets you go back and forth from one to the other. So let's postpone more discussion about this until the OWL chapter.
Thank you.
Okay, great. Thank you, Andy. Excellent question. So let's move on to the next GitHub question.
Okay, all right.
I'm thinking the second one looks a little friendlier. So how does RDF deal with multiple frames of data? For example, celebrity Obama versus President Obama.
Yeah.
Are they linked to the same entity?
So yeah, this is a good question for really exploring RDF. And in some sense, RDF is mute on this. You can do this by selecting IRIs any way you darn well please. And it's actually kind of similar to the answer to the previous question about properties versus classes, except this is at the data level. So you could have one URI for Obama, and you might use the DBpedia one, whatever that, a lot of people like to use DBpedia ones, and then link all this stuff to the same one. And then you would have the issues of possible contradictions. And this is actually exactly the example in the book about Pluto. Because you have the astronomical Pluto and the astrological Pluto. Are they really the same thing or not? And so in one example, we had it's what figure, I might be able to find it. Yeah, I turned right to it, figure 2.3. And if I were really clever, I'd bring up the PDF and put the figure on the screen, but that might take too long. You can turn to figure 2.3. What we're seeing there is you've got the same Pluto being described. And actually, this is a very parallel situation to what you're asking here. And in this example, we've treated them as the same entity. When we superimpose these two graphs, the Pluto in section A and the Pluto in section B were considered to be the same, which is, I think, your are they linked to one same entity? That's the strategy that this diagram is taking. And then the problem from that, as described in the text, is that, for instance, you have two pref labels, right? So, gee, you're supposed to only have one pref label. It's pref symbol, I guess it is. You're only supposed to have one pref symbol. Now I've got two. There's some problem there. Now, from a commonality and variability point of view, this can actually be just fine, because you say, in fact, A is published by one entity in one place in one file, as it were, or in one URI on the web. B is published by another one. So the first one was the Astrological Society. The second was the Astronomical Union. And yeah, they're saying different things about the same thing. That's going to happen. And yeah, Bill mentioned the Morning Star and the Evening Star. Yes, that's exactly what we're talking about here. And so we can go ahead and say, this book talks about Pluto this way, this book talks about Pluto that way. And if you combine those together, you might get some contradictions or some confusions. Or you can do the other thing that the questioner is suggesting, where you would actually keep separate URIs and say, okay, Pluto, the dwarf planet, the actual object out there, has this URI, and we'll say these things about it. And Pluto, the astrological entity, has another URI. And then we could logically talk about the relationships between these two things and describe it that way. And both of these are perfectly acceptable and useful modeling practices. And in fact, I would say that a lot of the craft of modeling is to understand what the trade-offs are for doing those things. Would you rather model files, as it were, sets of triples, or would you rather model triples? And that really has a lot to do with your infrastructure. Conceptually, you just need to make sure that you're keeping track of what's what. And Bill's comment about the Morning Star and the Evening Star is absolutely on point.
Let's see. Okay, so Jim says we will also see explicit ways to handle all of that we just talked about when we get to RDFS plus and SCOS. So I think that's chapter
7 and 8, I think.
I was going to say that. Okay, great.
I think that's right.
So anyone else want to join in at the moment? I have one question. So, and maybe this is better for chapter 7 and 8, but you say that, depending on which way you choose to model it, you just have to keep track of that. So I can imagine keeping track of all these triples can be quite a job in itself. Is there any particular best practice for that?
Well, in some sense, keeping track of triples is the same as keeping track of web pages. It's actually a problem that we already know. And a lot of the solutions there are ones that we already use. So things like web servers and file systems. Actually, I remember a comment that Jim Hendler said to me many years ago. It was actually at the University of Maryland, Jim. That gives you some idea how long ago this was. And I forget what system you were describing, but the comment you made was, we realized that people already understand how to manage files. They understand what a file system is. And with RDF, you can just drop a file into a directory or take it out. And if what your system is doing is saying, merge all the triples in this directory and do something with them, that now you get to manage your triples as something that you've been managing for decades, well, however long you've been working with a computer, which is a file. And that was a very interesting comment that he made way back. You know, when did you leave Maryland, Jim? It was that long ago. That comment, I think, can be taken more generally, that all the ways that you manage generalized files, so resources on the web, URIs, and then of course the files inside of the file system, and so on, that all of these ways that you've managed those things are actually applicable to managing your sets of triples as well. And so to some extent, you're right, it's a big issue, but it's not a new one. And so it's one that we've actually been doing for an awful long time with lots of different types of files.
Got it. Okay, so another question, this one from Matthias. Could you speak about the RDF star and Sparkle star proposition?
So that's a big question. And one of the lacunas in this book, I think, is that we did not write a section about RDF star and Sparkle star. And that's partly because of how long, even in this century, the runway is between actually writing a book and having it come to print, that it wasn't so clear that these two were going to be such a big deal. So I'm going to speak from a fairly pragmatic standpoint, in that I've been doing semantic web applications for, I don't know, a decade or more, and semantic web training and research for another decade before that, and then whatever you would call the prototypical stuff before semantic web for another decade before that. And while formal reification, that actually relates also to that formal reification question, I'm going to kind of bring these together because they kind of they touch on the same thing. And I've needed to use the formal reification that I describe here, I believe, on exactly 0 occasions. And now that's kind of interesting that you've got this formalism in RDF that I don't use anyway. And then you've got a whole proposal for expanding RDF in a way that makes this easier. And maybe I would use it more if it were easier. But there's a lovely blog entry, which I now will have to look up, by a colleague of mine. His name is Bob Ducharme, where the title of his blog is something like reification is overrated, or reification is irrelevant. I think that's what it is. Reification is irrelevant. And he's talking about the formal reification. And you can sort of take that one step further and say that RDF star and Sparkle star are irrelevant. I think that would be a bit premature. But the basic point of his blog, and I'll track it down and put it into our notes here, is that when you've got some relationship that you think you want to reify, and one example that I think he uses is the flight goes from San Francisco to New York, and it's on this day, and it costs this much. And so you have the triple, San Francisco connects to New York, and then you reify that and add a bunch of data onto it. Or you could realize that actually that link is not what has a price. If you've ever sat next to somebody on a plane who paid more or less for their trip than you did, you realize the price is not connected to that. It's connected to something else. So you might say, well, there's actually a thing called a flight. And we have a word in English for it, a flight. And in fact, it's easier to speak this way. The flight departed from San Francisco and landed in New York, and it took off at this time, and it arrived at this time. And actually, the flight doesn't have a cost either. The flight, because I got it from Priceline, the flight has an offer from somebody to sell me the flight for a price. And if you talk to people in finance, I remember researching FIBO, I was in a meeting with some very high-level financial data consultants. And the youngest, or actually the least experienced consultant in the room said, oh, I see you're not finished with stock. You don't have a price for your stock. And the most experienced consultant in the room bit his tongue. And I looked through FIBO and said, well, no, we don't. What we have is a thing called an offer. And the offer is for a financial instrument, actually for security, and a stock is a kind of a security. And the offer has a price, and furthermore, a whole lot of other stuff. And then the most senior consultant in the room said, yes, there are day open offers, day close offers, midday offers, and went through all of the kinds of offers that there are. By the way, there are also bids. So no, a stock doesn't have a price. A stock has offers and bids. A flight doesn't have a price. Actually, a connection from San Francisco to New York doesn't have a price. It has a flight. That flight doesn't have a price. It has an offer. That offer has a price. So if you actually think about every space you wanted to reify or wanted to use Sparkle Star or RDF Star, Bob's point, and I find it, it's a blog entry, so he can be bold, is every time you're doing that, sit back and think a little bit. There's probably some actual modeling that you ought to be doing, that you're going to actually find something in your domain, and maybe even a word like flight or bid or offer that the people who are serious in the domain really use, and then model it that way, and you're back to plain old Sparkle and plain old RDF. And so that's the point of his title, that reification is irrelevant. Now, he's writing a blog entry and making a very bold point. I still think that Sparkle Star and RDF Star have a place, but I'm not finding them to be this huge lacuna. And how was Sparkle ever let out of the gates without this capability? Yeah, I've been using Sparkle and RDF for over a decade, quite usefully, without having to do this. And mostly it's because that senior consultant in the room who wanted to put in the bids and the offers, that's my client, not the junior one who wants to get something that sort of makes some basic sense and gets out the door now. And that might just be my own practice. So I've said a lot of controversial things there. Let's see if anybody, I see some hands coming up here. So
we have Andy Fitzgerald. Go ahead.
Yeah, thanks. I don't want to dominate this with all the questions, but that great example, thank you. And the other, maybe to come back to a simpler example, in just language, we have transitive verbs and non-transitive verbs. And if you have a transitive verb like, I bought a book, the I bought alone doesn't, there needs to be the object that goes with that verb. And I've seen, the reification was my question, and I've seen reification as one way to deal with transitive verbs in English when we have an essentially binary system, which is RDF. And that reifying I think schema uses a purchase action, which is not very natural, but a way to model it, is that seems to be a case where that reification makes sense. Would you extend Bob Ducharme's argument and say that even in that case, is there another way that we should be thinking about modeling something like those simple transitive actions?
Yeah, I guess your example, I almost feel like you cut your foot off in that example. There's a word for this kind of action, and you used it. It's called purchase, right? Or sale. And there are brokers, and what do they say? Yeah, I closed a sale today. The language slams that word right in your face, and you've got an entire profession who will talk about closing sales. And guess what? I feel like I'm repeating myself. When you get the senior person in the room who's actually doing business and actually is making a living, talk to a real estate agent, and they'll say, I closed a sale, or the famous Glengarry Glen Ross thing, coffee is for closers. If you don't close that sale, you don't get any coffee. Yeah, there's a thing. And you know what? There's a board in that room that he was walking by with all the sales on there to say, this is the one who made it. And guess what? It's not binary. There's actually there's the broker in the sale, there's the purchaser, there's the seller, there's the mortgage broker, there's the title broker. There's, you've bought a house, you know how many players there are in that. And guess what? You get a stack of paper this big that you sit down at, guess what? There's an event at which the sale happens. Guess what it's called? It's called a closing. All these reified things have words, and you've just given an example where it didn't, and well, actually, yes, it does. And now there probably are examples. If you dig, I find them to be the exception, not the rule.
Thank you.
Okay.
How are we doing on time, Ellie? We're actually looking down the barrel of the end of our session, so we might want to start figuring out how to plan what's coming up next.
Yeah, well, I think we got a good question to kind of round things out with. Is it fair to say RDF star and Sparkle star are a response to property graphs
Of
and an
course.
attempt to align RDF with property graphs?
Of course they are. Yeah, yeah. And Bob's blog is, of course, a response to that response. And my little rant that I just went on is a response to that response. And I think from that point of view, that RDF star and Sparkle star are a great thing to do. Because from a developer's point of view, there's a bunch of things that you can do with a property graph that are tricky in RDF. Now, Bob and I can sit here and talk all we want about how if you just did your model, put your big boy pants on and swim with the most senior consultant in the room or that real estate agent, this is the right thing to do. But that's because we're coming at this from a sort of a data lake, data warehouse point of view. We're trying to turn that data warehouse into web scale. And this is why I always begin all of my classes with distributed systems. That's what we're doing. We are building a distributed system. Web means distributed. And if what you want to do is to have a distributed system that can grow, and that's what the web is, and that's what the semantic web is for, you really need to pay attention to this stuff. And I now get to go full circle back to the first question you asked, the elements of a good semantic model. Now you've heard some very specific things, that if there is some relationship there that somebody in the domain has given a name to. Why? Because that's the way they actually keep track of their work. Then this is where the competency questions come in. Can you write a competency question that would get at that? And in as much as you can, competency questions are pretty good. But this is why I'm kind of skeptical of competency questions. Would somebody have thought of that question? What do you call the event that you go to when a sale becomes complete? Would you have thought of that as a competency question? Probably not. If you instead gone the way that Andrew did and said, well, gee, I've got this transitive relationship and I need to talk more things about it. Do I have a word for that transitive relationship? Well, but that's actually not even a competency question. You could make it into one. That's more of a formal process of exploring the domain based upon things like transitive and intransitive verbs. I feel like I've gotten lost on the question, Ellie. Bring me back home. Reel me in.
The question was, right, is RDF star and Sparkle star a function to kind of add property graph capability?
Yeah, and the answer is just yes. I mean, that's kind of obvious. That's and even just historically, that's obvious.
So I think that we did also kind of touch base on Andy's question about formal reification.
Yeah, I see that as being the same as the discussion we were just having.
Yeah, so we basically agreed that reification is fairly rare, right? That was the point.
Well, I don't know if we agreed. That's what I agreed on.
That's what Dean said. So we can
definitely don't agree.
Yeah.
Well, okay, so we have Michael Rick who wants to join in. Go ahead, Michael.
Hi, Dean. It's just a question about the table 3.8 in chapter 3.
Okay.
When you're outlining some triples there. And I just wanted to find, going back to the following the lines of the elements of a good model as such, I suppose. So you talk about especially when it goes like bio, Anne Hathaway, bio married, and it goes lit Shakespeare. So why wouldn't you do a bio William Shakespeare, for example? Would that break something?
Oh, yeah. Actually, I'm wondering if that's, well, so thank you for that question, because that allows me to go to the one topic I told Ellie I wanted to make sure we got to before the end of the call. And here we are 7 minutes before the end of the call, and I can get to that. So those prefixes and URIs and modularity are things that I chose when I put together the example in the book. And I was fairly haphazard about that. And it could be that that's actually a misprint, but how would we find out? So I should put a link to this in the wiki. If you go to workingontologist.org and well, I'll put that into the chat and ask Jeff to put that into the wiki. All the data is actually there. And oh, but the Shakespeare one is, hang on, the Shakespeare one must be here somewhere. I was just looking at it a second ago. Maybe I don't have a link to it. Well, here's something that you can do, and I'll do that right away. So if we come down here to workingontologist.org, I'll start there. And if you copy this out of the book, which is what I'm going to do right now, workingontologist.org, and you can also click it through if you've got the electronic version. There are these URLs for that, and those are all alive on the web, and you can actually look at their sources. There it is, workingontologist.org/examples/chapter 3/ oh, that's manufacturer. This one is what, Shakespeare. Okay. If I got everything spelled out right there. Nope. If I got it right, then I would have got some content. Let's see.
One thing I noticed, if you did HTML to PSH, I got that. If I just said straight without SSL, actually,
yeah. Thank you. That's what it was. I should probably fix that. Okay. So now we can actually look at the real data. So the table that you asked about, Michael, are you the one who asked about that? Yeah.
Yep.
Is actually triples, so it's as a table, but it is not a TSV, it's actually triples, and those triples are in here. And I've just asked for, well, and since these are hash URLs, you actually get everything when you do this. So this is the Shakespeare, which is that namespace. And if I were to do biography, then I'd get this one. And it looks to me like, actually, I think bio:"Anne Hathaway" is a misprint, because I'm not seeing Anne here. Do I see her in here? There's Judith. Love Flavors Lost. Yeah. Okay. Michael gets the prize for finding the first typo in the book.
Yay.
Yay. Okay. So, thanks for your keen eye. That is a seriously keen eye. Wow. And that's one of the reasons to have the data online. So the thing that I wanted to talk about was that every one of the URLs or URIs in here as a URL, and whoever made the comment, we need to make sure we get the HTTP right, because all these things predated the secure web, will actually yield you a set of triples that you can use to do the kind of trick that I just did. I just researched Michael's comment to see if it was right, and indeed he was right and the book was wrong, by actually looking at the data. And so if you come here, and it looks to me like what I've done is I've also forgotten to put a link in here to Shakespeare. I've got the link to the products, but not to Shakespeare. So that's a website thing I can fix right away. Just make a note of that. I don't see it on there on chapter 3 data. So that you can look at all the data in the book and double check. So next time you see one of those, Michael, and say, gee, that doesn't look like a namespace, or that looks like you misspelled that, or that triple is in backwards order, the S is the O and the O is the whatever, grab the URI, plop it in there, or look it up on this page and dig the data out and see if what the data says. I've actually vetted the data pretty well. Obviously, I haven't vetted the website so well, so that all the queries starting from chapter 6 onwards against all these data sets all work. And I validated all of that. And so there's actually some validation to the data. But the reason to provide the data is so that people like Michael can do exactly what I just showed you on the screen. They can double check what they see in the book with what's in the data. And and if they find an error like that one, report it to me, or you don't need to report this one to me because I was here. Okay, I need to turn this over to Ellie because we're
last question.
2 minutes.
Yep, he's noticed a few more errors. So where can people submit those?
I think I should do is, why don't you know what? Let's use the GitHub. Let's just use that issues thing, the anonymous one, or create an issue yourself. If you're actually for errors, go to the GitHub and go to the top here, and go to issues and new issue, and just and in the header of the issue put the word errata or error or something like that.
Perfect. Okay, so that rounds it up for today. Thank you everybody for coming. Hopefully this was an interesting first session. Our reading for next time.
Oh, I have a quick question. The assignment, the amount of reading for a week, was that appropriate? Too much? Too little? In the chat, say just right, it was too much or it was too little.
I think we can do a poll.
Yeah, let's do a poll later on. Okay. Yeah, Ellie's good at putting together polls.
It was a little too much. I think that so we're getting fun, perfect. Yeah. I think that next week though, the
Is
reading,
a lot less.
yeah,
It's a lot less
so
next week.
it'll be
But
better.
when we get to chapter 6, it's huge. Chapter 6 is like twice as big as any of the chapter. So I'll warn you the week before we get to chapter 6 that you'll need to set aside some time to read through it. It's also very detailed, it's Sparkle. So you're going to be hunting around. So a little bit too much. Okay. So, all right. We got to go, don't we? Because I've got another meeting to be at right now. So
Okay, so thank you.
Thank you so much, Ellie.
Of course, I will actually stay on the line. If anyone has any problems or questions logistically, just stay and we can chat.
Okay, I'm going to leave. Bye-bye.
Bye, Dean.